3.
Wow, that's doing well, thanks. Nice to be here.
May I call you Lou?
You may. You certainly may.
Okay, Lou, so thank you for joining us on Astro Radio tonight. I've been reading up a little bit about you, but there is so much that you've done in your life. I think we're going to go and start right back at the beginning. So how did you decide to take up a career in spaceflight and IT?
Well, I'm going to have to rely on my mother for that, because she tells me that when I was 3, I had a room, a bedroom with a south-facing window, and she would rock me to sleep singing a song about the man in the moon. And sometimes, because it's a south-facing window, she'd point out and she'd say moon, and I'd say moon. And that was all she wrote. By first grade, I was having star parties in my backyard with my little 3-inch reflector, and by 3rd grade, I was giving talks on the planets to my classes. So it was quite early, and that's not unusual for astronomers. Maybe 3 is a little early, but to get involved, to get interested, really get the passion for it, maybe in elementary school.
Yeah, we had a lady on the other night, and we were asking her the same question, and she said she was 4 when her parents took her to see the solar eclipse down in Cornwall here in the UK, and that was her inspiration. So how did you start out in astronomy? What was your first career move, if you like?
Well, let's see. I guess the first career move was working in the astronomy department at the University of Maryland as an undergraduate research assistant. And I was working with the great Frank Kerr, who was an Australian astronomer, a radio astronomer, used a lot of the data from the Parkes radio astronomy observatories. And we were mapping out neutral hydrogen in the galactic plane to see if we could define the structure of the Milky Way a little better. So that was great. I mean, I got paid almost nothing, as I remember, but I didn't care. That was just fantastic. So from there, I think at that point I went to Goddard Space Flight Center, and for a year I was working on some total ozone measurements, just cataloging data and all the stuff that you get to do if you have no stature, if you're just a young, fresh out. And then I found out about this position at in the Voyager mission, the Voyager infrared spectrometer called IRIS. The infrared science team was at Goddard, and they were looking for someone to support their instrument and manage the program from the private industry side. So I applied and I got the job. And one of the reasons I got the job is that the principal investigator, well, the co-investigator, Virgil Cundy, who became a great friend of mine, I had worked for him in high school. I had a summer internship with him in high school where we were trying to take ground-based observations of the atmosphere of Venus. And, just what a surprise, here he is again. And so he hired me, and that was my Voyager career.
With Voyager, I mean, what would you say was the highlight of the Voyager missions for you?
Well, for me personally, it was the very close encounter with Titan, or with Voyager 1. They sacrificed the rest of the mission for Voyager 1. It did not go on to Uranus and Neptune, just to get very close to Titan, because we knew that Titan had a significant atmosphere. We knew there was methane in the atmosphere. We had some pretty decent, as best you can do, ground-based measurements. And so we knew it was a real target of opportunity. So I used a lot of the infrared spectra from a sequence called SATAT, where we would scan down from off the planet through the LEM down onto the planet to try to figure out what kind of gases were in the atmosphere, how they were condensing out, all that kind of thing. That was so exciting.
Yeah, I mean, as a youngster, I remember, you know, the images coming back from Voyager were just astounding, and I still get a buzz every time I see those images from Voyager. How did you feel when Huygens actually landed on Titan eventually from the Cassini probe?
The Huygens landing was amazing. And of course, the science that we got from it, albeit at one place on the planet, but still the science we got from it was incredible. The images, the downward facing, nadir facing camera, seeing the fluvial flows, they call them. We'd call them rivers, right?
Yeah.
And seeing real evidence of liquid on the surface, that was incredible. But the part that really amazed me was that the people who do the celestial mechanics and do the trajectories and are able to pinpoint this thing that's 10 AU away, and they nail it within I don't know how a kilometer or so. It's like magic.
Absolutely amazing. What I'm going to do now, Lou, is open up questions from the panel, because I know there's so much. I know I'm talking beforehand. Lots of them have got questions for you, so I hope you don't mind answering a few questions.
No, bring it on.
Okay, Dave, away you go.
Thank you very much, Pete. Okay, before I pass you around the panel, I just got to quickly say I remember Voyager's getting launched back in the 70s, 1977, September, thereabouts. And I remember thinking, I wonder if I'll ever see it get to the planets, because this was going to be the grand tour, wasn't it? I think that's what it ended up as.
Right.
And as a young kid, amongst the many things, as you say, collecting buttons, we used to collect cards that were in the packets of tea. And in particular, it was Brute Bonds, and they'd have an album that you'd take the cards, and you'd take the card out the packet. That would go in the album. It'd be butterflies, stamps of flags of the world. But the one I loved was the Race into Space, and one of those cards was the Grand Tour, and that became the Voyager missions.
Wow.
And watching it launch, and then actually seeing it get there and produce those images. And as Peter said, watching those images come back, at that time, they were fantastic. You look back now and think, okay, they're not that great, but at the time, they were top quality, weren't they? And the only the only way I could get decent images to do a talk at my local club was to actually photograph the television screen. No videos at the time, couldn't freeze frame, couldn't pause a YouTube video or anything like that. It was literally my Zenith camera on a tripod in front of the television screen, taking exposure about 125th of a second or 130th of a second, and hopefully don't get one of those scan lines diagonally across my screen. But those images were fantastic to see. Volcanoes on Io, and just amazing. But yeah, great memories. And you just reminded me of what it was like to watch that television and see those documentaries back then. And it was out of this world, literally.
Well, fantastic. Here we are 40 years later.
Shh, don't say that.
Earth years. And still, the images of Uranus and Neptune and their moons and rings are the very best images we have.
Yeah.
Because we haven't sent anything else to those planets. So
that's it. But maybe at some point we'll get
quality.
Yeah, maybe higher resolution. Okay, I'm going to open it to the panel. Mary, and I'll hand over to you first. Have you got any questions or any comments?
I was interested in your work on solar physics, actually. I was very late getting into solar observing, and I absolutely love it. And one of the questions I get asked a lot when I talk about eclipses is, do we still learn things by watching eclipses, given that we have spacecraft studying? I was just wondering what your opinion was on that. What do we learn from eclipses now?
So the magic of eclipses is that the moon is almost precisely the same size as the sun, right? Sometimes it's a little bigger and we get a full total solar eclipse, and sometimes it's a little further away and we get an annular. But what we like to do is we like to block out the photosphere when we take our measurements so that we can see the very, very tenuous solar atmosphere, the corona. And the devices that we use to do that are actually end up being much bigger than the actual diameter, apparent diameter of the photosphere. So there's a part of the solar corona much closer to the surface, well, I'll call the surface of the sun, that we don't see in those cases. But during a total solar eclipse, the moon is so close to the actual size of the sun that you can see all the way down into the chromosphere. So it's still useful. There is still research being done. The 2017 eclipse most recently across the United States, there were a few different research teams that were looking for composition and temperature in the solar corona. So yeah, we still get a little information.
I was in Glendale State Park for that eclipse. It was our honeymoon, and it, honestly, everyone told me I'd cry, and I was like, no, I won't. But the emotion really took me by surprise when you actually see one. It got me big time. I do a talk on that trip, and I still choke up at certain parts of it. It really got to me.
Isn't it incredible? This is the heavens moving, and and those photons are your photons. They're there just for you. They've entered your eyes. So it has that effect on everyone.
No, it's amazing. I know that whenever I've been to Astrofest, we quite often get talks on new discoveries about magnetic fields around active regions, and it's all just so new, a lot of the research. So it's something I follow closely.
It is an amazing event to see an eclipse, and I always say anyone who's never seen an eclipse, you need to get out there. 98% partials don't come anywhere near total. 99 is nowhere near total. That 100% is magic, and you can't stop it. Once it starts, from the partial phases to the first contact, you cannot stop it. It just continues, and you just got to stand there or look through a video camera, which is not the best thing to do. You've got to use your eyes and just watch nature all around you go crazy. Human emotions is amazing.
My first eclipse trip was back in 1999. I took my daughter, who was 8, with me, and we went to Paris. And we toured Paris for a while, and then we joined a planetary magnetospheres group who went up to, I think, Soissons, is it? To this old burned out abbey. And I was lugging all my telescopes and gear, and I had it all set up with 2 tripods and telescopes. And I had a picture of me with an umbrella over my head as it's raining. So
things happen, don't they? You can't control the weather either. That's life.
I've actually seen that picture. Lou sent me his presentation on that just the other day. I've had a look through it. So I'll share that with the rest of the guys if you don't mind, Lou. Actually.
Yeah.
A group of our society went to Mongolia to observe a total eclipse, totally fogged out. So there they are, just total, I think it was snowing, but it was just total fogged out. Or the cloud had come down, nothing at all, and they couldn't do anything. Maybe build a snowman, but that's about it, really. But you can't do much, can you? If it's cloudy, you just got to take it, and it'll go dark. If it's clear skies, then wow.
I did one thing that I probably shouldn't even say in an open forum, because
There's only 250,000 people listening to us. It doesn't
no one should do this. But so it's cloudy, but with a larger aperture, you can kind of see a little bit through the clouds. So I took the solar filter during the partial phase. I took the solar filter off of my telescope, and I used the clouds as my solar filter. Don't try this at home.
Just say for the listeners out there, not really recommended, because ultraviolet and infrared radiation can still come through that cloud. You can still get a suntan on a cloudy day, apparently.
Right.
Don't risk it, but there we go.
Unless you're in Britain, Dave, those clouds are guaranteed to block anything.
Well, you certainly block our stars out, don't they?
Even a supermoon for tomorrow.
Oh, supermoon.
Oh, God, no,
I cringe when I hear supermoon. I cringe.
I hate that word.
Moon's always super. Crescent moons are super. Yeah, look at Daz. Yeah. Okay, over to you, Andy.
No.
Oh, thanks, Dave. So I cried during the 1999 eclipse as well, but only because it was completely clouded out in Cornwall. And I got into astronomy when I was 2. when my father put me on his shoulders in the garden to see, I think it was either Echo 1 or Echo 2, one of the early satellites. And of course, in those days, a satellite crossing the sky was a big event. It actually made the newspapers that there was going to be a satellite visible. So I remember being on my father's shoulders and seeing this point of light crossing the sky. And he put me on his shoulders because it was very low in the sky. We had to peer over the neighbor's fence to see it. And from that moment on, I was absolutely hooked. But my father had been telling me since then that in 1999, we were going to go and see the total eclipse together. And the first thing that happened was my father, unfortunately, had a series of strokes and he was too ill to travel. But I went with the rest of the family. And the day before was brilliant sunshine. The day after was brilliant sunshine. 5 miles either side of us was brilliant sunshine. We just had a wodge of cloud over Falmouth in Cornwall. And you know, I mean, we still got the darkness and we got the magical shadow racing over the water towards us. But, you know, missed it really. However,
I remember it well, Andy, as well.
Yeah, I know. You were there as well. It's just, you know, my thought was, how could the universe play this trick on me? You know, it's known for years that I wanted to go and see this, and you know, what's it saying to me really, that you know, somebody up there hates or something. But anyway, what I was going to say to you, Lou, was regarding Voyager. Are we still getting new useful science out of Voyager even 40 years later?
We are
still going on.
Yeah, each of the Voyagers, as you may know, have pierced the heliopause. They're moving outward from the sun at about 3 AU per year, 3 times the distance from Earth to the sun per year. And so they are now the first human-made mechanisms in true interstellar space. They have 4 or 5 instruments that are still operating and still sending back useful data. These are fields and particles instruments that are measuring not the solar wind now, but interstellar winds and interstellar magnetic fields. So it's still very much operational, and it has a nuclear power source that will run out someday. And I think there's some hope that perhaps with cycling instruments on and off, they can keep the thing, keep Voyager working and sending back data till about 2027, which would be the 50th anniversary of its
that'd
launch.
be good, wouldn't it? That'd be great, wouldn't it?
We'll see if they make it.
Well, let's hope they do. What about scientific discoveries from the grand tour, if you like, the tour of the planets? Are we still discovering things in the Voyager data, or is it all been mined?
Well, a lot of it's been mined, and there are a couple of issues here. You could probably divine more discoveries out of the Voyager data, but we now have new data. We have Cassini data.
Yes.
We have Galileo data.
Yes.
Right. We have Hubble Space Telescope observations of the outer planets, including Uranus and Neptune that Voyager visited. So there's a lot of data on the ground that probably is still hiding some secrets. But
this is why we need to go back to. Sorry, go on.
Yeah, I can guarantee that as much as possible, the discoveries from the Voyager data have been pretty well mined by now.
Sure, and this is precisely why we need to go back to Uranus and Neptune, because that's the only data we have about them. And
you should talk to Heidi Hamill about that. She's a strong Uranus-Neptune supporter.
Well, I've been reading about NASA's sort of vague plans to, at some point, you know, within the next decade or so, think about another mission to the ice giants. The technology's moved on unrecognizably since then. And what we could discover now compared to what Voyager could discover, I'd love to live long enough to see another trip to the ice giants. That would be phenomenal.
And in some ways, because of Voyager and other missions. So, for example, with the Galileo mission to Jupiter, when its antenna didn't open fully, we had to get creative and solve the problem of very low data rates. So the sensitivity of the Deep Space Network was increased. They changed the way they were packetizing and sending data back to the Earth. So all these new things that we learn with each successive mission, we apply to the new missions that we send. So everything, not only people, but I guess missions stand on.
I think, oh, no, we're okay. We're still
there.
Still going.
Thanks very much, Lou. Dave?
Thank you, Andy. Okay, Lou, we'll go over to Gary. Any thoughts, Gary?
Hi, how are you doing, Lou?
How you doing, Jay? Nice to see you.
I think Gary knows Lou. You're all right, Lou.
Well, we met a couple of years ago. We've only ever met up once, but we've been in touch ever since, haven't we, Well, basically, obviously, everybody knows you've now worked with NASA for, well, you did work with NASA for over 40 years. A couple of questions. What would be your most memorable moment for working with them for that long? Be it either any mission-based projects or a teaching moment or anything like that. Oh, and also, could you also tell us a little bit more about comparative planetology?
Oh, well, let's see. Let's start with the first one. Most exciting moment. It's hard to pick just one. I remember there was a time when I worked with my mentor, Bob Samuelson, who was just an amazing. He is just an amazing scientist and planetary researcher. So he kind of shepherded me through, and we were looking at the Voyager data one day, and everybody else had access to the data, and there were different opinions from the same data set as to what's going on. And the big issue at the time was methane clouds on Titan. Were there methane clouds or were there not? And I remember being at Cornell University, which was a place for one of the annual Division for Planetary Sciences conferences. And I think we were in the audience. Maybe we had already given our talk on methane clouds, and there were two other groups. And Carl Sagan and who he was working with, Thompson, they were another group who was looking at that problem. And then I think there was a Canadian group looking at that problem. And we all three of us had different views of what reality was from the same data. And Bob and I thought, well, maybe not methane cloud. Sagan and his team said, absolutely methane clouds. And the Canadian group said, no way, there are no methane clouds. And it was just fascinating, the different interpretations of the same data sets, and the little, I won't call them arguments, but good debates that happened as a result from people who felt very strongly about it. And today we know there are methane clouds in the atmosphere of Titan. So
definitely a reason to go there as well.
Yeah, absolutely.
So obviously you're working a lot with the comparative planetology, and you do a lot of modeling and things like that on the systems. Could you tell us a little bit more about that?
So you're probably referencing this for the course that I want to teach in the fall at Marymount. So I have taught astronomy at Marymount University labs and lectures for a long time, and I wanted to teach a class in planetary science, but Marymount is a liberal arts school, and so the courses that I teach are for non-majors, film majors, criminal justice majors, fashion design, not astronomy. So they tend to focus on the liberal arts, and there isn't a lot of money to start a new course in planetary science. So I think the deal that we worked out, I think this is still going to happen, is that I'll teach the regular survey astronomy course, everything from sun, earth, moon to cosmology. But I will always do it from a planetary science perspective. Celestial mechanics works with the planets, formation and evolution of bodies, both planetary and stellar bodies, works with the planets. The issue of astrobiology and life outside the Earth is very much a planetary issue. So I'm going to try to teach a survey course in astronomy using the fundamental, understandings of planets, and we'll see how that goes. It could flop. I don't know.
I think Daz had a little bit more to ask you about this, actually.
Yes, if you don't mind. Hi, Lou, and thanks for coming. As regards the comparative planetology, it seems to, as you said, encompass a lot of disciplines, i.e. geology, hydrology, atmospheric physics, and interactions such as impact craters, space weather, and magnetospheric physics in the solar wind, and possibly biology or astrobiology, as you said. That's off the top of my head, of course. Yeah. So is the idea, because I also noticed that you do some work through the SETI Institute. Is it sort of like aimed towards possibly finding microbial life or anything like that? Because the only baseline that we've got, comparative baseline, is Earth, isn't it?
It's the only place that we're certain that there's life. There have been confusing results, for example, from the Viking landers. Their gas chromatograph and labeled release experiment produced confusing results as to whether or not there's microbial life in the dirt that was dug up. But the work that I'm doing with SETI now, and that is, you're right, SETI, the Search for Extraterrestrial Intelligence, that's their mission. But we have a grant, a NASA grant, that was given to the SETI Institute to work with Girl Scouts and to train Girl Scouts in astronomy and teach them how to run their own astronomy clubs. So each year I bring 10 councils who compete for this, Girl Scouts, along with amateur astronomers from their council, out to Goddard. Of course, this year we'll do it virtually, and train them in sun, earth, moon to cosmology, and then give them tours and star parties and all kinds of things, and then show them how to run an astronomy club. So then we send them back to their councils. They start Girl Scout astronomy clubs and bring in more girls. And then I keep in touch with them each month with a Zoom telephone. So that's the work I'm doing with SETI.
Oh, excellent. Excellent. And what sort of take-up have you had for your course?
What interest?
Yes, what sort of interest have you had? Is it a full course?
Oh, the course at Marymount?
Yeah.
I usually get about 15. I teach, right now I'm teaching back-to-back laboratory courses. I get 15 students per class, roughly. When I teach when I've taught the lectures, it's both of those combined, about 30. So it's usually pretty well attended.
Oh,
and the deal there is that they have to take a science. They're afraid of physics. They're afraid of chemistry, so astronomy somehow seems like a more palatable choice. And so I try to make it fun and engaging and tell a lot of jokes and a lot of other things.
And it looks like it will also introduce them to other sciences as well, as just due to the content. Excellent. Thank you very much for that, Lou. Thank you.
Thanks, Gary. Thanks, Daz. Okay, Peter, are we ready for another track, I think?
Yep, we'll be going back over to the chat very shortly. This is Zone Tripper and Alpha Centauri signals.
I just love the way Peter pulls out astro tracks.
Yeah.
Sometimes it can be on the theme, or if you have a
He
particular.
doesn't need a database, He's got them all up there.
They're all up on the top of the cuff. Certainly are.
I must apologise, folks. I'm really quiet. I didn't finish work till 8 o'clock.
No
So,
problem, Kath.
so if I don't say much intelligent, not as I usually do, but if I say less so, that's just because I'm absolutely exhausted. So, but I'm listening with great interest, Lou. It's really interesting. Thank you. I'm just going to go and grab a piece of toast for my tea.
Okay, Kath, we'll keep you towards the end. When you come back in after your dinner.
After I've had a piece of toast, I might have my brain cells in action.
That's it. What are you having on the toast? Butter or
peanut butter? Peanut butter.
Crunchy or just smooth?
I've got smooth at the moment, open, but I do have crunchy as well. So yeah, but
okay, Ron's just joining us.
I've been really into it at the moment. My neighbour's got it into me. We went to the park with the kids and she did like sandwiches and she did peanut butter and strawberry jam. I thought, this is going to be absolutely disgusting.
The moment it starts getting cool, the temperature drops, the light levels drop.
With Alpha Centauri signals. This is Pete here on Reach Out and Touch.
It happened exactly as you said.
On Astro Radio, of course. If you want to get in touch, Pete at Astro Radio.
Okay, Rach, we're going to go on to you next.
Going to go back over to the chat where I've got a question from Stefan in Moscow for Lou. Lou, Stefan says in Moscow, he said, do you actually own a telescope at all?
Oh, sadly for my wife, I own far too many telescopes. We just moved into a new house up in a place called Newmarket, Maryland, a bit north of Washington, D.C.
Yeah.
And part of the reason we picked this house was because it has about 2/3 of an acre of land that borders a cow farm, and so not many trees, very clear horizon, perfect for building an observatory. I think I have on the order of 15 telescopes.
Wow.
Is that including the spot and scope as well?
No, that's not fair.
Well, my wife tends to think the spot and scope, the finder on my telescope, is also a telescope, so that counts as 2. And she thinks I've got 9 telescopes. I can only count 6.
I can actually vouch for this because Lou recently, a few months back, got married to his lovely wife, Susan.
Yeah.
Congratulations.
Thank you.
And she actually took some photos on the morning of the wedding of the flowers, and sneakily in the corner was a telescope.
Was the telescope best man or best person?
Well, that's one of the reasons we moved. I had a what do you call it, a townhouse or a row house, or kind of small house,
like a terrace house type thing.
So I had telescopes in the living room, in the kitchen, and everywhere else. So now they're just half of the garage. So until I get my observatory built.
Do you use them quite regularly?
I'll tell you, I find that I use them the most when I'm showing other people.
Yeah.
I don't. I mean, maybe that'll change when the observatory is there. I don't have to lug everything out, but I love helping people watch the sky and having star parties at my house. And sometimes I'll have my undergraduates out, and sometimes for my church, I'll we do a silent auction. I'll auction myself off for a night with the astronomers. So
very good.
And Tien in Japan, he said, what's the largest telescope you've got?
I have a Star Splitter 18-inch f5 Dobsonian. That's my largest.
Wow.
We're coming to your house, Lou. We're coming on a visit.
Come on down. It's a lot of fun, but it's also really heavy, so that it's not my go-to scope.
So will you be building an observatory from that in your new place then?
That's right. So so it's out there already set up, roll the roof off or whatever. And
fantastic.
Makes life so much easier when you just roll that roof back.
But on the subject of showing people around the night sky, this was why the advent of go-to telescopes was fantastic, because I used to invite people around to look in the telescope, And 90% of the time, they'd be standing in the freezing cold, stamping their feet in the cold while you tried to find something with the telescope. And of course, that's no fun for everybody, and it's guaranteed to turn people off astronomy. Now, of course, when the Meade ETX 90 came out, which was the first amateur go-to scope, I was first in the queue. And at the push of a button, I could just say to people, right, we're going to look at, I don't know, Polaris now or M31 or whatever it was, push a button and the damn telescope would go and find it and track it across the sky. I mean, this was magic to me, and you could get through so many objects in an evening. And of course, you could also download different tours, because it was the first telescope to connect to the internet. So you could do a tour of stars at different ages, showing them young stars going to very old stars. And of course, when there was a new comet, you could download its orbital elements so the telescope could find it and track it. I mean, this was pure magic to me. And it made showing people around the night sky so utterly, utterly pleasurable. And it enthused a lot more people than I've been able to do previously. So
that's the fun of the education of the astronomy, isn't it?
Yeah.
I know Rachel is interested in the education side. Well, what's your thoughts, Rach?
Yeah, hi Lou. Apart from imaging, my favourite thing is definitely inspiring the children and just making sure that astronomy is accessible for all. I think that's a real big problem. There's so many children interested but don't have anyone to guide them or even anyone to point them in the right direction of where they could go. And I do what I can. I do lots of work with scouts like you and do some talks. And obviously, once you get them here, you're so excited to offload everything you know without scaring them. But obviously, it's cloudy a lot of the time. So when you can't take them out and point them at something through the scope, what's your golden nugget of information that when it's cloudy, you think, well, this will wow them. You don't need to see this, just listen. And what do you tell them?
Well, So that's wonderful hearing that you work with Scouts. I've been working with Girl Scouts for over 20 years in various capacities. And along the line, I was also working with my daughter's elementary school. I have 3 daughters, and they both went through this same French immersion, actually, elementary school. And so I started an after-school astronomy club in their school for grades 3 through 5, which you have the same.
Yeah, I think it's roughly about the same. We call it year, but yeah, I think.
So it was right after school, so it's not dark outside. And so most of what we did some solar observing, but most of what we did was inside a classroom. And I discovered 2 things. I discovered they love competition. So if I couldn't do anything else, if everything had failed and nothing worked, we would have a competition. And I'd split the class up and let them, the club up and let them come up with their names. And I'd ask them questions. If they got it right, I'd put a line on the chalkboard. They lived and died for those lines on the chalkboard. They fought furiously for those lines on the chalkboard. And the other thing that they loved was things that collided or exploded. So we would do what we call pop rockets. We take little film canisters, fill them with water and Alka-Seltzer tablets, and let them, shoot off. And they'd have to estimate how high and what percentage of water and what percentage Alka-Seltzer. So those kinds of things they just love. They just got attracted to them. But when I would take them out to the telescope, I've got one telescope, 20 elementary school kids. The boys are on the side playing ice hockey with pieces of ice because it's winter. The girls are over here chatting amongst themselves, and then it clouded out. So we looked at license plates on cars.
Thank you.
One of the things that, as you say, when it's cloudy, you've still got to entertain and show what the telescope can do. One of the questions they always ask is, how much can it magnify? Well, yourself, if you want, you could actually magnify 10,000 times. Wouldn't be very good, but it can, in theory, do all this. But I usually try to show them something on the horizon. And from our observatory, we're up on a hill, and we can see quite a distance. For those obviously in the northwest, I know Ron will know, Ellesmere Port. And in the distance, there's an oil refinery on the river. And that oil refinery burns off the waste gases. and you get basically a flame like when you see the oil derricks at sea, you see the oil burning off the gases, and it just looks like a giant prominence. So I usually say to the especially the youngers and to the fathers and mothers as well, as you can see the little orange light on the horizon, and the squint in their eyes. Yeah, I can see that. What is it? And so let's get the telescope on it. And when we put the telescope upside down, depending on the telescope, of course, when they see this flame burning away, they're actually mesmerized, because some of them have come halfway to visit us from that distance. So they know exactly where it is and how far away it is. But more interesting is that they always point out the detail that you can see in the flames as the flames are licking. And it's the detail they can see, that's a good thing for resolution, is it? Because you bring in your aperture of your telescope, focal length for magnification and so on. But it's one of those things of getting around on a cloudy night. Otherwise, you've got to keep on talking, and you talk for 2 hours. It could play on the old vocal cords, as I'm sure you know. But there we go. Right, Sonia, what do you do?
I could say just to Rachel one more
Sonia.
time.
Sorry,
Rachel,
Lou.
if you are working with Scouts, we should talk by email. I have lots of other activities if you're looking for them.
Yeah, that would be really, really useful. I'm also a primary school teacher in the day as well, so we are looking at doing an astronomy club next year. So I would have lots.
Great. Let's talk. Let's talk.
Excellent. Is this what they call networking? Is it? Isn't it great? This is what astronomy is about. It's just
it's schmoozing, Dave. Schmoozing.
Schmoozing. I like the word schmoozing. It's rather good.
Professional schmoozer.
I'm going to schmooze over to Sonia. Ask Sonia, have you got any thoughts, Sonia? What do you do on cloudy nights?
Oh,
I meant that nicely. Sorry. I've got
so in 2018 when we got married, we did the whole honeymoon thing. We did the whole the Disney World, the Universal, and of course I had to pester do the Kennedy Space Center as well. Unfortunately, we didn't get to look around the complex as we looked around we did the whole coach tour for the whole day of where the liftoff were and everything like that. And everyone was talking about, it would be absolutely dream come true to work at NASA. And everyone who I work with now, and everyone's on the street, and like, you would want to work at NASA. I'm like, absolutely, yes. If I lived over there, where I would. So this comes to my question for you, Lou, of take your memory back to that very first day when you started at NASA. What was your thoughts and what was your feelings, entering the NASA building, knowing you was going to be working that very first day for them?
Well, that might depend on what the definition of the first day is, because I as I mentioned, I worked for NASA through a NASA American University summer program when I was in high school. I remember you know what I remember? I remember the smells of computer paper and laboratories that had, kind of oil and mechanisms and things like that, and old books. That's what has stayed with me. This smell that says, wow, there's research going on here. I was I was stunned that I could actually be in a place where everyone around me had the same interests I did, which wasn't, generally the case in high school or as I was growing up. And the projects that they were doing just mesmerized me. So it was exciting. It was really exciting. And I remember. Is there
any specific projects now, if you got the chance to go back to NASA and said, would you come and work on a project? Is there any specific project now that you would want to work on?
Oh, absolutely. Absolutely. There's a mission being designed by APL, Applied Physics Laboratory of Johns Hopkins University, called Dragonfly.
Ah, yes.
Yeah, yes.
And it's in development. And Dragonfly is going to send an Arrow rover to Titan. Okay, kind of like Ingenuity on Mars now, the helicopter that flies around. They're going to do the same thing on Titan, which I think it sounds like magic.
Yeah.
That will be a neat project. And
but it's not, as I understand it, it's not going to land until 2034. So all I have to do is survive another 13 years on this planet, because I'm not leaving this planet without seeing that. I mean, that would be unthinkable. So
I'm with you on that, Alan.
yeah, absolutely. Yeah, so we all need to look after each other and stay safe and keep COVID at bay. Because I want to see Dragonfly. I want to see Titan close up.
Oh, that would be amazing.
Because we've only got a few photos from Huygens, and we need to know a lot more about Titan, because I reckon Titan is holding many, many great secrets. That's my guess.
I just think Titan is amazing because it's got lakes, and we've seen the nearest thing that we can have to waves on that type of surface. But it's more ripples, I think, across as opposed to waves. I don't think you're going to surf on them. But it's just amazing to think there are lakes on another.
There are barely ripples. The latest estimate says that the ripples on the lakes of Titan are at their highest 2 millimeters high. So
really, no surfing there then. We'll forget the surf.
It's virtually a mirror surface on those lakes, because
it's still fascinating to think it's a lake all the same.
Well, and ants could surf on it, I guess, or something.
Yeah, maybe.
Yeah.
These are hydrocarbon lakes, of course, hydrocarbons and nitriles.
Yeah.
But Titan doesn't weigh very much. Its density is only about 2 grams per cubic centimeter, less than half of Earth's. And that means that there's a lot of water ice below the surface. So some models predict oceans, liquid water oceans under the surface. And that's where you'd look, that's where you'd start looking for life, I think.
Deep down, eh?
Yeah, very deep down, presumably. So.
Yeah. Okay, Sonia, anything further you want to add? Sorry,
was that, sorry?
Sonia, anything further you want to add? Any more questions?
No, that's good for me, Lou. Thank you.
Thank you, Sonia. Sorry, Andy, we'll come back to yourself if you don't mind. Michael, you're into the space, ghost space, obviously.
Yeah.
What's your thoughts?
Yeah, I mean, it's great to speak to somebody who's involved with Voyager, for instance. You mentioned earlier about Voyager 1 having its trajectory curtailed, if you like, at Saturn because of wanting to interview Titan. Was that a big decision? Were you there when the decision was made? Was there controversy about doing that at all?
I was not there when the decision was made. I joined the Voyager team just barely after Jupiter encounter.
Mm-hmm.
So these plans were already solidified. However, when we send instruments that far, when we send spacecraft that far, you load them up with instruments, right? Because this is a major effort. So between all of the instrument teams, there's a little give and take that goes on. You have to compromise, because one team might want to look over there and at say the body, the planet, the moon, and another wants, no, we want to look over here at the rings, or that kind of thing. Yeah. So there is controversy that goes on in instrument teams, but I don't remember there being controversy about that.
Right. Okay. And you mentioned Dragonfly. What are your thoughts on the other missions, like for instance, Lucy going to the Trojan asteroids, and that would be not be involved in things like that?
Could you say that again?
Yeah, I was thinking of the Lucy mission that's going up later this year to the Trojan asteroids.
Oh, the Trojan asteroids. Yes. Well, how exciting! I mean, we're still learning about how the solar system formed, and what it's not only what its past is, but what its future could be. We know, for example, that the planets where they are today are not where they were all the time in their 4.6 billion years. There's been migration. Uranus and Neptune formed in closer, and Jupiter and Saturn migrated in and out, these grand tack theories, this kind of thing. So we're still learning a lot about the formation and evolution of the solar system itself, and being able to go to these Trojan asteroids and understand their composition and their dynamics is going to provide us with a lot of information about that.
Yeah. Right. Thanks.
Okay. Thanks, Mike. We've got Peter with a question, I believe.
Well, yeah, I was sitting there listening and I was thinking, what were your reactions when we got to Pluto and when you saw the images of Pluto coming back for the first time?
All of our exploration, certainly into the outer solar system, has been a huge surprise. The diversity of morphology, for lack of a better word, the discovery of volcanoes, the bland appearance of Uranus, the more exciting appearance of Neptune. It's all been a big surprise. No one had any idea what Pluto looked like.
No.
We imagined it was a large comet, perhaps, member of the Kuiper Belt. But to see it up close with the diversity of features on its surface, with this dynamic surface that's churning as we watch, and as well as Charon and its other moons. I mean, it's just incredible. It's a massive surprise every time you encounter something else. And then, of course, they went on to, New Horizons went on to Ultima Thule. And that was a huge surprise, So it's interesting that you design a mission and you have to kind of know what you're going to find, or you can't make the case for funding. But you never find exactly what you think you're going to find. It's always this amazing excitement and surprise.
Well, would you agree with me, Lou, that I think the lesson from studying the outer solar system is that I think everybody expected these worlds to be cold, that far from the sun, no energy, nothing moving, completely inert. And yet we found activity everywhere, even in very low energy conditions, like on Triton, for example, with its geysers. I mean, Triton, I think I might be saying, is about the coldest place in the solar system. Yet there's activity there. So, is there ever any real planetary body that is completely inert? Because this I find the major revelation from exploring the outer solar system, that there's activity there, and where there's activity, potentially, given the right conditions, there could be life. So, I find the whole thing absolutely stunning. I really do.
That was a huge surprise in the Voyager mission. So on Earth, the sun heats the ground heats the air rises, you get winds, you get precipitation and so forth. So we thought, well, as we get further from the sun, and the number of photons per square meter drops off as 1 over r squared, so things get cold real fast. We're not going to find any of this. We're not going to find winds and things of that nature of any consequence. But in fact, we found the highest wind speeds in the solar system.
Yes.
On Saturn, I think as 10 times further from the sun than we are today. So. It's all a big, that's why we explore.
Thanks. And I believe Peter was about to ask you the question he asked everybody about Pluto.
I will ask the question, planet or not?
Oh, planet or not? Well, in a way, this has been a wonderful controversy because it's brought the public along in this mission of discovery. Everybody's interested in that. Everyone asks. So officially, of course, it is a dwarf planet. But that's just because the rules were set up that way. As we were discovering more and more objects out in the Kuiper Belt, some as large as Pluto or almost as large, Eris is almost as large, we had to make a decision. Astronomers had to make a decision. Do you invite all of these new bodies in, and now we have many planets, or do you cut it off? And so, the story. The International Astronomical Unions got together, formed a committee, and said, well, let's come up with 3 criteria. And the first is this body has to orbit the sun. It can't orbit another planet. So Titan and Ganymede and Callisto, they're bigger than Mercury, but they're not planets. The second is they have to be big enough to be round. So if you think of taking a big pile of snow, like you might make a snowball and crunching it in on all sides, that's what, when you're big enough, gravity will have some other odd shape. Pluto meets those criteria. The third criteria that it doesn't meet is that it has to be massive enough to sweep out its orbit of debris. And Pluto doesn't do a very effective job of that. But for goodness sakes, it's got an active geological surface. It's got moons. It's got an atmosphere. I mean, what do you want? What do you want to be a planet?
It's spherical.
For me, it's always going to be a planet. Whether the rules say or not, it's a planet as far as I'm concerned, and that's the way it is. But anyway, we're going to go to another track now, and this one is another suitable track. It's called Planet Caravan by Black Sabbath. Got a question in from Rob in Norway.
Thank you, Peter. Certainly have. Hi, Rob in Norway. Hope you can hear us nice and clear. So Rob wants to know, Lou, how do you feel about the success so far for the Mars Perseverance and Ingenuity mission?
Well, we have come a long way with Mars. The early days of Mars exploration were, really pot-marked with failures for both us, for the United States and the Soviet Union at the time, who were the only countries at that time sending probes. It was just very difficult. And we seem to have figured this out now. We seem to have figured out how to get a spacecraft to Mars, how to put it into orbit, or how to kind of ram it down Mars' throat with aerobraking and get it to the surface safely. So this 7 minutes of terror that people talk about as we send a spacecraft directly into the atmosphere of Mars and are out of communication with it for 7 minutes, it's getting a little less terrifying because we're being pretty successful. The Perseverance rover is exciting for one reason, and that is that it's leaving canisters of Martian soil on the surface. That a mission in the future, we send missions every 2 years because of the orbital dynamics between the two planets, that a mission in the future will pick up and bring back to Earth for analysis. So first sample return from Mars is going to be very exciting. Ingenuity is pretty cool because it's kind of a combination of these two kinds of missions. One kind of mission is a science mission. You go there, you take measurements, you look at things, you touch things, you figure out what is going on with the science. But another kind of mission is an engineering mission. And that says, let's just see if we can do this. Let's see if it's possible. And then later on, we'll maybe add some instrumentation. But Ingenuity has both. It has a real science purpose, which is to scout out good places for the Perseverance rover to go and to get images of the surface. And also, as an engineering mission, we've never done a powered flight of anything on another planet before, so that we can do this, especially on a planet with as thin an atmosphere as Mars has, about 1% of the density of Earth's atmosphere near the surface. It's remarkable. There was one other mission. The Soviet Union sent the Venera mission to Venus, which released a balloon with a payload. So it's not the first time we've flown in any other planetary atmosphere, but it's the first time we've had a powered controlled flight on any other planet besides the Earth. So how exciting is that?
It is. It's massively exciting. Massively exciting. Who's up next with a question?
Well, we've got another question from Jill in Dublin, and she's asking, what do you think we can learn by going back to the moon in person? Personally, I don't think I'll be going, but maybe some of our younger listeners.
I thought they'd invited you.
No. Maybe wishful thinking for some people, but they can't get rid of me that easy. So yeah, about sending humans back as opposed to a robotic, automation. What's your thoughts, Lou?
Well, the bang for the buck, if you're just doing pure science, it has got to be with robotic explorers. It's much cheaper to send robots, but there's something about the human spirit that says that we are explorers. We have always been explorers. We have always looked over the next hill. It's in our DNA. It's just what you get for being human. Every time a kid skips a rock across a lake to see how far he can get it, that's extending your will beyond your current means. So we are explorers. There's no way around it. But beyond that, there are some real reasons that we might want to go out with human beings into the solar system. And if you take a little bit of a either realistic or pessimistic view, depending on where you stand, it's for the survival of our species. We're going through what appears to be the 6th mass extinction in the last, 500 million years or so. And the Earth, we find out, is actually a rather delicate place. We're floating out in this void with all this shrapnel left over from the formation of the solar system. We're doing the best we can, I guess, but we're really, really playing with the Earth's environment, with global climate change and so on. And there are these mass extinction events that happen that destroy over 50% of the marine and land life on Earth. So it's a delicate planet. We are delicate beings. And if we are going to survive, if our species is going to survive, in my opinion, we need to reach out into other worlds. So in that sense, going to the moon going to the moon to stay, that's the plan, to stay now, to have permanent habitats, is a necessary first step into establishing larger colonies of people on other worlds. And that may simply be something we need to do to preserve the human race.
Yeah, I just feel having a human there, they can make decisions, whereas a machine will have to be programmed, or it would have a routine set, and it can't think, it can't change or think around or out that box. It's just logic, isn't it? Yeah, I think humans makes a difference.
More and more, or less and less, depending on how you look at it, we are able to program some of these probes that are going out, well, for example, to Titan, right? We can't, we don't have a joystick. We can't fly it around. The one-way light time is too long. So we are doing a better job of putting artificial intelligence and
But are we not seeing that on Mars at the moment with its helicopter? It's not literally remote control and live. We've got to wait for that delay for the signal to get there. It has to have some pre-program so that it's automated with some intervention in between, I suppose, and then the signal has to be sent back. It's having hands-on literally makes that difference, I think.
Well, I think Dave as well. You think what one human geologist on Mars can do, and how long it would take the Perseverance rover to do the same thing?
Yeah.
Nothing beats the human eye. If there were, I'm sure there isn't, but if there were a fossil in a Martian rock on the surface, Perseverance could just roll straight past it and not even see it. Humans are very good at picking out patterns, abnormal patterns in things. This is why we need to get human eyes on the ground, let alone anything else, because we're very good at pattern recognition.
But we've only actually had one scientist on the moon, haven't we?
Yeah,
was it Harrison Schmitt?
Harrison Schmitt,
yeah. He was a geologist, so well, he could see. He understood exactly what he was looking at. That was his.
But I think that has changed because Apollo was done for national glory and to poke the Russians in the eye.
But it's science towards the end, perhaps.
Now with Mars, I think you know, they will mostly be scientists.
Yeah.
Of one discipline or another, and I think that's going to be unbelievable. So I must give Elon Musk a donation to get the Starship there quickly.
Okay, have a word with them. Okay, Keith. What's your thoughts, Keith?
Hi, Lou. Yeah, it's interesting what you said about spotting things in rocks on Mars, because I used to be a geologist, and there's no doubt about it, they can ferret things out surprisingly well.
Yeah.
Unfortunately, I was too young to go to the moon, and now I'm too old and too heavy to go to Mars. So I'm not going to be going there.
It's only a third of the gravity, Keith. You'll be fine.
They've still got to get me off the Earth first. But it's also interesting, some of the comments earlier about education and public outreach. I used to have an observatory in my department, and you know the sort of sinking feeling you get when somebody says, can we bring round a scout troop to look through your telescope on May the 6th, 2000 and whatever, and you think the weather's not going to be very good. Anyway, so we used to use as backup some open source freeware called Celestia, which allowed you to tour around the solar system in 3 dimensions and indeed space. And Celestia would not have been as stunning as it was without those images from Voyagers. There's no doubt about it. I mean, and when you can sort of go around Uranus or Neptune and look at some of the moons and all those pictures, all those surface pictures that they've used in that software have come from Voyagers 1 and 2, well, Voyager 2 in particular, of course. And thank you is all I can say. You know, you've made my life a lot easier and inspired a lot of children along the way.
That image of the crescent Neptune and the crescent Triton next to it. It's one of my favorite images of all time. It is just so beautiful and so inspiring.
I couldn't agree more.
Yeah.
Anyway, I've got a couple of questions to ask. I've better put my question asking hat on. Hang on a minute. Right. Okay, so
for our listeners, Keith has just put on his NASA hat.
The first one is, you mentioned earlier on about the low density of Titan and indeed the other moons of our solar system planets. Quite simply, how do we work that out from using space probes? I'll let you answer that one, then I'll ask the second one. Yeah.
Well, in order to get density, you need volume and mass, right? So you can fly your spacecraft by the planet or by the moon, and you can notice how much its trajectory is shifted, right? As the gravity of the moon, in this case, the moon pulls on it. So you know the diameter of the planet, you can work out the volume. And now you can know how massive it is, because you know that's a direct link to the gravitational pull, given the distance the spacecraft is. And from that, you get a density, at least a bulk density. You get a bulk density. After that, you hand the problem to the theoreticians who know something about planetary and satellite formation and the abundance of materials in the outer solar system. And so you come up with these models that, in this case, say that there may be liquid water oceans under the surface of not just Titan, but Enceladus and I mean, you know, Europa. In fact, it may be quite the rule rather than the exception that you have these. In general, the outer solar system is much less dense than the inner solar system, perhaps because hydrogen was more available after the early Centauri sun kind of did its thing with the solar wind, and also that water could condense in the outer solar system where it was colder. So.
My second question is, everyone regards Titan as one of the most fascinating objects that's been seen on the Voyager missions, but for me, it's the moon of Uranus called Miranda. And I must admit, if anyone's listening in at the moment, look it up on the internet now, because it's the most astonishing object. What were the general conclusions drawn about its structure and how it came to be the way it was?
let's see. So I'm trying to remember which we're talking about, the moon with the
patchwork quilt surface.
Right. So I think the idea is that there is there's a leading edge and a trailing edge. And so it may be picking up material on its leading edge, but also it looks like it kind of came apart and was put back together. So there may be some sort of a, because there's very clear delineations between surface features, right? So it may be that in fact it met with some collision and then kind of regrouped.
Quite impressive, really, isn't it? I mean, you wonder how it didn't just become completely turned into, say, a ring round Uranus rather than recoalescing the way it did. It's extraordinary. Yeah. Well, thank you. Thank you very much.
Sure.
I'll take my hat off now.
Leave it on, it looks good. Thanks, Keith. Okay, we've got a question coming from Phil in Cornwall, here in UK. If using your telescope, Lou, what is your always go-to object?
Go-to object? Well,
you can binoculars or eyes, whichever.
Depends on what's available.
Yeah.
And what I'm doing. So if I'm with people, if I'm with a group of people and I'm showing them, and Saturn's available. Saturn always pleases. Jupiter and its moons are incredible. They're so easy to catch, right? You know exactly where they are. And so you can use the big daub on them and don't have to have setting circles or whatever, or go-to mechanism. So the planets are great. Beyond planets, I love there are two globulars in Orion that are pretty easy to sight. If you have a big enough aperture, the double star in Cygnus, Alberio, is beautiful, showing clearly the blue and red this double star system. And if it's dark and I'm feeling a little more adventurous, I go after M51. I go after the Ring Nebula. No, that's not M51. It's, what is it?
M51's the Whirlpool.
Right.
M57.
57 Ring Nebula.
57.
Yeah.
So those
both,
are kind of
both excellent objects. Yeah. But what latitude are you at, Lou? I was just thinking of your objects. What latitude are you at?
We're at about 39 degrees north latitude.
Right, yeah, so you get some good southern skies. We obviously, in the UK, we don't get those southern skies. Scorpius doesn't get very high. We have Antares. We just get the, where its claws would be, but we don't get that sting.
You should see it from here, Dave. It's fantastic.
All right, don't be rubbing it in now. Okay, Kath, you've got a question there, I believe.
Yes, well, one of my questions has just gone. So my other one, I'm fascinated by books. I love to read books. I used to work in a library for years, and I can see you've got quite a collection behind. So what is your favorite book on a space topic? And also, if you had somebody coming to you who was a beginner, wanted to start out, what book would you recommend to say, here's a good basis for you?
Let's see.
I love it. Love it when someone goes to their bookshelf.
Yeah, but it might be one of his own books.
It might be. That's okay.
Which is fine. That's acceptable.
Absolutely.
This is one of my favorite books. This is an old book, a life science library on the planets. And when I was young, my aunt and uncle, this is 1967, would send me a Time Life book. And once they sent me this on the planets, and I read it cover to cover. And what's interesting about this is it's got a lot of information that's still true today, and a lot of information that is not. And I'm trying to find it here. The discussion of Venus is really caught my attention, because in 1967, we didn't know what the surface of Venus looked like. Well, maybe I won't find the images. Here it is. let's see, this is Mars. Mars. So we didn't know what the surface of Venus looked like. And so here are some possibilities. A carbonated sea, a petroleum planet, perhaps. Something even weirder. So I just love this book, not just because my aunt and uncle sent it to me, which is very special, but because it tells me about how far we've come.
Yeah.
So this, that's perhaps unexpected. It's not something I would use today necessarily, but I have talked about this book before, and I've kept it. A good starter book. Gosh, I don't know. This is an interesting book. This is called Vlad the Astrophysicist.
Oh, wow.
For our Transylvanian astronomers.
Yeah,
that's amazing.
So it's about a young man who looked up at the sky, and it's easy to read. It's doesn't have little text.
Oh, that's really cool.
I'm just wondering if the follow-up book is The Werewolf and the Full Moon.
Oh, stop it.
Well, maybe for some.
Yeah.
Lou.
How many books would you say you've got, Lou?
How many? I don't know. I still have books in boxes. Of course, we just moved, and 4 months ago, but we're still putting the house together. So I have books upstairs. I have books in boxes in the basement.
Wow. And are you still buying books?
I am, but don't tell my wife.
I was going to say, I have that problem in my house. Because I live with my aunt, and every time I buy a book, she said, she says I have to get rid of one if I want to get a new one in, so I have to sneak them in. And I haven't told her about the 2 boxes of books that I haven't unpacked since we moved 1.5 years ago.
It's the same in the studio here.
And she's probably listening now into it, Cav.
Hopefully not.
Lou, shouldn't your favourite book be your daughter's book on astronomy?
My favorite, what kind of book?
It should be your daughter's book.
Oh, well, okay. So for the 2017 eclipse across the United States, before that, my daughter Kara wanted to write a book about the eclipse, and she has a friend who's a marvelous illustrator. And I don't think I think that I have boxes and boxes of these books down in the basement. I don't have one here, but she wrote a children's book, and I encouraged her to target it at middle school girls, because that's a group of, we tend to lose, well, all students at least in the United States, we tend to lose their interest in science right around middle school. Before that, science and astronomy and dinosaur, everything is amazing. And after that, not as much. So she targeted it at middle school girls. I helped as a kind of science reviewer. And the book reads, it's a little girl whose mother wakes her up early in the morning and says, we're going to the eclipse. And the little girl is really not sure she wants to do this, and it's early, and she has other things she'd like to do, but she goes with her mom. And she meets all these interesting people. She meets astrophysicists and artists and amateur astronomers and on, and figures out that she likes astronomy, likes space. So she takes a picture of all these people she's met, and the very last page of the book, that picture is on her desk, and she is a doctor of astronomy. So it reads a little bit like, oh, thank you, Susan, thank you. My wife heard me talking and brought the book in. So It's
I also heard about buying the book.
I was wondering if she was listening at the door.
Yeah.
I'm in big trouble. I better
We should have said they were library books. You'll never know.
I'm sorry, I got you in trouble there. I'm so sorry.
Sonia,
I'm in big
Sonia,
trouble.
you're sacked. You're sacked.
I didn't know she was listening round the corner.
Sonia, you're fired.
I need my books.
Oh, okay. So
No, they're just library books, honest.
I have a reprieve. So this is Jordan and the solar eclipse. And the illustrations are all, here's an artist that she met. And actually one of my dear friends, Parmesh Dwivedi, who works at NOAA, National Oceanographic Atmospheric Administration. He kind of shepherded her for a while. And so there's a character in the book called Parmesh. So it's just kind of a neat, it reads kind of like every eclipse, every transit I've dragged her out of bed for her whole life.
What an excellent memory, though. It's something to keep, isn't it? Yeah. Okay, Simon, have any thoughts, any questions on the subjects of, well, I don't know, Mars or the Voyager missions?
I suppose I've always felt sorry for Mars. If you go along, sort of got tiny Mercury, then you've got Venus is massive. You've got Earth that's pretty big as well. And then suddenly Mars seems to have got the short end of the straw, as it were.
Right.
It seems a bit of a shame. Are we all to just blame Jupiter on nicking all its stuff?
Well, that's actually a good question. Why is Mars so much smaller? Venus is about 95% of the Earth's diameter. Mars is about half. Why is that? And some very clever people who do amazing modeling have looked at possible ways that the solar system formed and what might have happened. And one possibility is, I'm sure you've heard of this ninth planet. One possibility is that as it made its very elliptical orbit coming.
That is assuming Pluto's still a planet, then we'd have.
Okay, then in that case, the 10th planet.
It could be 10th planet, couldn't it?
It's 10 solar mass planet.
Let's not get into that, sorry, Pete.
Perhaps it disrupted the material that Mars would have had to form from. But yeah, it's kind of diminutive. It's kind of small. It's hard to see. You know, you have to wait every 2 years, or you don't get a very good look at it. But it's certainly getting a lot of attention.
Yeah, it's getting plenty of attention at the moment. We've got a question coming from Derek from Liverpool AS, and he asks about the helicopter on Mars. With model helicopters on Earth, if it falls over, sometimes they can self-right themselves. Can that happen with the item on Mars, the helicopter on Mars?
I don't know.
If it falls over, is that
no
it?
idea.
Yeah, I've never thought of that one. I suppose it's feasible. It could happen.
I don't know. I'd have to think about it. I guess if it falls over, then its blades are in the dirt.
Yeah.
I don't know if they can get the blades moving in order to jar it into an upright position or not. I don't even really know.
Let's hope it doesn't happen. Yeah.
Maybe Perseverance can come over and kind of nudge it up.
That's well, we were talking with Peter earlier on. I'm waiting for the image looking down on the craft. We've seen its little rover tracks. I want to see it sitting there looking back up again. It hasn't happened yet, but it will do. I'm sure Peter will process the image for us. He's doing quite a lot out there in the background.
Yeah. Dave, I think even if it did crash into the dirt, every second that Ingenuity survives on Mars is a bonus.
Of course, yeah.
The scientists are very happy that we've got this far. So if it died tomorrow, they'd still be very happy.
We've got our money's worth. Is it possible? I'm getting asked again. Is it possible for the rover to pick it up? Obviously,
well, that's what Gary just said.
Yeah. Can it be picked up by the rover?
Would it be able to be tipped over, maybe using one of the arms?
Technical kick.
Yeah.
Yeah, a bit of it. There we go.
A knock over with Sherlock.
Bit of a come on, mate, get up.
They just get one of the film crew to come over and pick it up.
That's it, because it's all false, isn't it? It's not
It's
real,
all
of
false.
course.
Yeah.
Yeah, when them blades were turning around, there was no wind kicking up the dust. Yeah, okay.
There was some guy in Iceland I was watching the coverage of the fantastic Iceland volcano, which if you haven't seen it, is just absolutely stunning at the moment. And one guy wrote in the comments on YouTube about the video, "Oh, isn't Iceland fantastic? No wonder they film all of the Mars videos there." And I said, "Hang on a minute, you know." And this guy was seriously saying that, you know, all the shots of Mars that we see are actually filmed in Iceland.
Well, actually, a lot of the testing for the lunar rovers and all that's actually done in the Canary Islands.
That's right.
Yes.
That's right.
So, so you got that wrong.
Yeah, absolutely.
Okay, we're going to go to a track in a moment. So before we do, Ron, are you on mic? I know you've had a bit of a problem with the microphone today.
Yeah, I am here.
And any questions, any comments?
Yeah, one question that crossed my mind, and apologies if I missed this with being a late arrival, but if you were sort of master of the universe and had unlimited access to funds and you could just authorize anything, what would be your dream project that you'd like to see kicked off for exploration?
So you mean if I had just a tiny percentage of our military budget to work with?
Yeah, that'd be the
one. Well, I think I'd like to see an interstellar mission. It seems quite far out of our technology at the moment, but maybe not undoable. Alpha Centauri is about 25 trillion miles away, and you would have to accelerate along that way, perhaps solar sails with lasers providing some impulse. It's unclear, and perhaps we don't even have the technology yet, but I would like to see the first interstellar mission succeed. Unless you consider Voyager an interstellar mission at this point.
Well, it's getting that way. Yeah, it's a long way out.
By the way, New Horizons just passed 50 AU.
Yes, it did.
Big
Yeah.
celebration.
Yeah. And while we're on the subject of Centauri, did anybody see that massive flare on Proxima Centauri?
Yes.
That
Yes,
was
I did.
one of the brightest ever seen in the whole galaxy. These red dwarfs may be small, but they pack a lot of punch, that's for sure.
And it does reduce your possibilities as where to go look for life, if you think about it.
Yeah,
we've always assumed that red dwarfs are a good candidate for having planets which support life, but looking at that flare, I'm not so sure.
No.
Yeah.
It turns out that most of the stars in our galaxy are small red stars. And they are, as you're saying, very flary. And then when you get into much more massive stars, they don't last enough time to burn their fuel very quickly. So it may be that our sun, and perhaps a little bit to either side, is the optimal type of star that you want to look at.
Oh, Luke, can I just put another question in? What do you think of the possibility in the future, and this is pure speculation, that with development of spaceflight carrying on as it has, that one day somebody will go out and collect those Voyager probes and bring them back again and put them in the museum?
There should be.
Well, didn't Star Trek Voyager already do that?
Yes, I think it probably did.
It's already been done. Well, not likely, I think, but. But
okay,
you know,
I think we're ready to go for another track now. Over to you, Pete.
Okay, we're going to go for another track. I'm going to play this one for Ingenuity. It's Thunderclap Newman and Something in the Air.
Oh, very good, very good.
Now I'm going to get off, folks. It was lovely seeing you all again. Nice to meet you, Lou. Hopefully we'll speak again soon.
Yep.
Bye, everybody.
About the last 10 minutes of the show now, folks.
Okay, Pete. Well, we're just chatting about what music do we listen to when we're out observing or when we're relaxing. So what does a professor listen to when he's observing?
Well, so I like Bach because it's intricate and it's precise. The Brandenburg Concertos, I think we had one of them playing at our wedding, as a matter of fact.
Wow.
And two-part inventions, how they weave in and out. I love Bach. I love Bach. I have a special place in my heart for Mozart because he did wind concertos and I play clarinet. So his clarinet concerto in 3 parts with a exciting, energetic rondo movement. Third part is just, it's one of my favorites. Finishing out classical, I guess Tchaikovsky, March Slav. So much energy. And then the soft kind of, what do you call it? Vertical, you call it vertical structure, right? With a lot of chordal structure of Debussy, Claude Debussy.
Oh, yeah.
So I like classical music. I have a favorite bluegrass band.
Oh, I like a bit of bluegrass.
Called the Hillbilly Gypsies.
Yeah.
And I think their banjo player won best banjo player in the state of West Virginia, which seems to me to be the best banjo player on the planet. So he's really
Isn't everybody in West Virginia a banjo player? That's some distinction.
Everybody. Yeah.
It's in the banjo. In the blood. It's in the blood. Yeah. Well, yeah. And do you actually play any instruments at all? Are you musical yourself?
I do. This is my little home office. Disconnect for just a
I thought you were
second.
going to say, it just so happened to have my guitar here.
Just so I have
I have
my church
my
organ.
synthesizers.
Oh,
over here.
right, yeah.
Oh, fantastic.
So I play a little keyboard, and
Yeah.
I'm not practiced much anymore, but I had been clarinet, sax, and flute were my other instruments, and a little guitar.
Fantastic. Yeah. Do you write music, Lou?
I do. I'm not for, just because sometimes the spirit moves you, right?
Yeah.
Gotta write the song.
I'm the same. It just comes out of your fingers sometimes. You've got no idea where it comes from or why. It just comes out of your fingers, and you've got to get it down.
Not these fingers, they don't. Sorry. What about William Herschel? He composed music, didn't he?
Absolutely.
Yeah, and that's available as well. Obviously, a famous astronomer.
I did.
And
William
some of his
Herschel,
music's
really?
available. I think you might like some of that. Ron, have you listened to any Herschel?
I actually went on to Spotify a while ago and just put in William Herschel just to see what would come up. And it was a mixture of sonatas and I think some concertos or symphonies. Can't remember now. It's a few months ago. But actually quite a surprisingly large range of music. And of course, he's the same era as Haydn. So it's very classical form. And to be honest, if you didn't know it, you'd think it was some Haydn that you'd not heard, but it's of that style, very sort of classical form.
Well, those who've been to my Herschel to Hawkwind talk will know that I do a bit where I'll tell you about Herschel. Before he went to do talks about astronomy and optic making, that was one of his other things, he actually played music before some of the talks. So he was the first astronomical and music festival guy.
Hey.
He was the
Pete
warm-up
Mark
act as well. Yeah.
Yeah.
Was Caroline musical as well?
She sang, played harpsichord, and
that's
also,
right. She sang, didn't she? Yeah.
Yeah, I've got some of sort of prints of music that she wrote, sheet music.
Wow.
I use those in the talks.
For those who live in Shropshire, the National Trust at Attingham Park, they have an organ in the main hall there. And I noticed last time I went through it, the music sitting on the stand of the organ console was actually Herschel.
Oh, nice. Somebody
I
will
go there
bring
a
you
lot,
then.
Ron, when it's open. Yeah. Just down the road.
Yeah, Simon's making notes. So that's where it went.
Thieves! We'll get it back. We'll get it back.
Lou, I should point out Simon is actually from Bath. These Bath astronomers, and that's obviously William Herschel land. And
Great astronomer.
Yeah, but
I didn't.
And
know
William
he
was too. Yeah.
He wasn't bad for an amateur, was he? What did he discover? A planet of some sort.
Planet.
That planet with the funny name that everyone
You're
sniggers.
right about that.
That's
Mind
the
you,
one all the kids snigger at.
He reported it first to the Royal Society as a comet. He actually thought it was a comet because it was so bland and so undistinguished. And, it's the most tedious planet in the universe, Uranus. It's just, and he said, he actually said something like, this is so uninteresting, I can't really believe it's a planet, but I'll report it anyway. And the Royal Society came back and said, well, no, we think it's a planet actually. So that's how it happened.
Be nice to Uranus. It's had a hard life.
I
Really
know.
hard.
Well, you see, I always say, sort of the playground bully knocked it over on its side just for being so boring, and it was so lacking in enthusiasm it couldn't even pick itself up again. So,
but what you're saying, that's the power of the Voyager images again, because Uranus has become more active since the Voyager 2 probe passed. But everyone sees the picture that Voyager 2 took when Uranus was at its most bland.
Well, I actually wrote to NASA during the Voyager thing, and they sent me back a series of 10x8 prints of Uranus from Voyager. I remember being severely underwhelmed because I thought, well, I could have just got a white coloured pencil and coloured a white circle in, could have done it myself.
Did it cost you any money? Did they charge you for that?
No, they didn't.
Well, therefore, you got no complaints.
I've also
I need to go over to Gary because we're coming to the close of the show. Sorry,
sorry.
Andy. Gary, you want to mention about a book?
Yeah, just going back to books again, I believe you're in the middle of writing a book with a bit of a twist at the moment on astronomy, Lou. Can you tell us a little bit more? Can you indulge on the twist at all, or
on the what I'm
the book that you're writing at the moment?
Oh, that yes. Well, yeah, I suppose I can. I remember being at a friend's house many years ago, and they had a hot tub out in there, outside, and we're all sitting in the hot tub, and the sky was perfectly clear, and they were all talking. I'm looking up like this. I just couldn't keep my eyes off the night sky, and friends of mine had been talking about maybe doing a podcast series on hot tub astronomy. And I found myself with a little bit of time, so I have a book I'm writing on hot tub astronomy.
Fantastic.
My kind of book, that is.
I actually have experienced that. A quick trip I had in the Lake District. We're in a hot tub, myself, my wife, and two other lovely ladies. And I just said to them, bear in mind, I just had a heart attack, got over my operation, triple bypass, and I'm sitting in this hot tub, clear sky. And I said, I can't believe I'm sitting in a hot tub with three beautiful women looking at the night sky. And we all just laughed. And
then you woke up.
So funny. And then I woke up. And at that point, it brought us 30 seconds to the closing of the programme. So I'm going to pass to Peter to finish.
Well, I want to thank you very much. Thank you very much, Lou, for coming on to Astro Radio tonight. It's been a pleasure. I hope you come back and join us. You're welcome anytime.
Oh, yeah.
I'd love to.
Been on the panel.
I had a blast.
Yeah, do come back and see us, Lou. Do come back.
And thank you to the panel for your usual professionalism. And we're going to leave tonight with a track that all astronomers could relate to. It's Black Sabbath. No, it's not. It's Deep Purple and Black Night.
Wow.
There we go.
Wow.
And I never got a chance to ask about gamma ray bursts either. That was something I was going to talk about. Because all gamma ray bursts that we've seen up to now, we've observed. Bear in mind, 30 years ago, we didn't know what these were. Sky and Telescope would come out and say, what is this object? We keep detecting these things. And if I remember right, it was space satellites, US space satellites sent up there looking down for gamma ray bursts from nuclear explosions, but they were detecting them from the other direction, which led to a question. And then we all it comes together. Actually, these are stars, black holes, maybe, or neutron stars colliding.
But it was nearly 10 years before they told the scientists about it. We had an extra 10 years of gamma ray science, but they kept it secret for so long. Typical military. Honestly.
But these are all gamma ray bursts in other galaxies. What happens if we get one in our galaxy? Is that a likely, or bit of an extinction event, maybe?
I don't want it to happen too close.
Sorry, Andy. Sorry, Lou.
Yeah.
If you don't want it to happen too close.
No, this is it. You see, but is it possible within our galaxy though for this to happen?
Well, I should think so.
Yeah.
No reason why not.
Why not?
We're just being lucky up to now.
Yeah.
Yeah, because there is talk that there may have been a GRB in our galaxy that caused the